Good morning. Let us get started with this chapter, Strategic Capacity Planning for Products and Services. Capacity planning is required whenever we design a factory. It is required when you hire a workforce. It is required when you design a restaurant. So you have to know how big your facility should be so that it can meet demand. We look into both long-term and short-term capacity planning. We'll also look into service capacity planning, which is a little different from product capacity planning. So let us get started with this chapter on capacity planning. So before we get into the planning of the capacity, we should understand what this capacity means in the business world. So it is the upper limit or the ceiling on the load that an operating unit can handle. So please let's stress on this term, upper limit. So that upper limit cannot be exceeded. So capacity can be needed while planning equipments, space, employment skill. So when you are making a building, when you are buying equipments, when you are recruiting people or training them up, this capacity planning is required. The basic goal, the broad level goal of capacity planning is to match the demand and supply. Again, you should understand for 99% of the cases, 100% match is not possible. So we try to get as close to the demand as possible. If there is overcapacity, that means we have built a capacity which is more than the desired demand, and in that case there will be the cost would be higher because your overhead costs are more. Your money is locked up in that business. The other scenario would be under capacity. When the demand is more than the supply, it is under capacity. In that case, you lose customers, which is not beneficial for the company, both for the short term and long term. What are the different capacity planning questions? So first and foremost, you should understand what kind of capacity is needed, whether it is space, whether it is equipment, whether it is qualified workforce. So kind, then how much, what is the number, like if it is a building, like how many square footage, it is 3,000 square feet, 4,000, how many equipments or how many workforce. Then it comes when it is needed. So that's also important. Do you recruit your workforce now or maybe in 6 months time when the demand actually happens? Now all this capacity planning is tied up with the cost. It determines the sustainability of the organization. It also important, like you plan your capacity, but you should understand whether the supply chain can handle the necessary changes. You increase your capacity, but can the supply chain handle it? Capacity decisions, it impacts the ability of the organization to meet future demands. So when we decide about capacity, we should think about the future. That's because you cannot keep on changing capacity every day. Once you decide on the capacity, you build your capacity, it stays with you for a period of time. Again, that period of time can be variable. It can be for a year. You are making your capacity for the next 1 year, or maybe it is built for the next 5 years. So it varies from business to business, but that future demand has to be kept in mind before you do your capacity planning. Okay, and also you should keep in mind the globalization. What are the changes happening in this global economy? How does it affect your business? How does it affect the capacity requirement? Now, capacity can be broadly divided into this design capacity, which is the upper limit. Then comes effective capacity, which you actually can reach. The classroom is designed for 50 students, okay, but maybe some of the chairs and the tables aren't working, or they are broken maybe. So the design capacity has come down to that effective capacity. Maybe out of that 50, 5 are malfunctioning, so the effective capacity comes down to 45. But actually every day we see that it is utilized by 30. So 30 is the actual output. So actual output is here. Okay. So this is because of some problems, some issues happening in the system. Once you understand the design capacity and the effective capacity, there are two equations you should remember and understand. One is efficiency, which is the actual output divided by effective capacity. And other is utilization, which is the actual output divided by design capacity. We need both, because if you just take into consideration the efficiency, it might give you a wrong picture, because effective capacity can be below design capacity, and in that case it might show a good effective ratio. The efficiency ratio may be high, but actually the things are not working properly. So we need both these ratios to understand the system efficiency. Design capacity for a distribution center or a warehouse is 50 trucks per day, whereas the effective capacity is just 40 trucks per day. Maybe some of the docking stations are not working properly. And the actual output every day on an average is 36 trucks per day. So efficiency is 90%, whereas utilization is 70%. So as a management student, you should understand that if you just take a look at the efficiency, which is 90%, you might be happy, or some layman might be happy, but you should go into more in-depth analysis and understand that you are utilizing only 70% of your design capacity, which is not good. So you should try to follow up on the situation and try to understand where the problem lies and how you can increase your design capacity, so that how you can increase your effective capacity so that it gets close to the design capacity as much as possible. What are the determinants of effective capacity? They are the facilities, the product and service factors, human factors, supply chain factors, external factors. Human factor is really important as far as effective capacity is concerned. You have some design capacity, but your employees are taking leave frequently. They're taking breaks frequently. Lunch break, tea break, coffee break, maybe a break to do some exercises. Well, those are required, but too much of those aren't good. So that brings down the design capacity to the effective capacity. And same happens with facilities. Say 10% of the facility is unutilized, or it cannot be utilized. So that brings down the design capacity to that effective capacity. The capacity strategies can be divided into leading, following, and tracking. In the leading strategy, you build capacity based on your forecasted demand. In the following strategy, you build capacity when the demand exceeds the present capacity. So you have built a building, but it is too small for the requirement, which is increased over time. So you add a new building. The other would be tracking, which is similar to following, but you take small steps. So if there is a small increase of capacity or there's a small increase of demand, you increase your capacity by a small amount. Then again there is a demand increase, you increase your capacity. So this goes on. So that is tracking. These capacity strategies are typically based on the assumptions and predictions. So again, for forecasting there were some assumptions. Similarly, for this capacity design there is some assumption, and the assumptions are long-term demand pattern. We assume that the demand pattern remains constant. Technological changes. A lot of this capacity planning is done now assuming that the technology will change, and we also take into consideration competitor behavior. Like competitor is going to expand their facility, so in order to match competitor you have to expand your facility as well. So these are some of the points which we have to remember while designing capacity. Capacity cushion. So the excess capacity used to offset demand uncertainty. Say your demand is 100 or the forecasted demand is 100. If you design your capacity for that 100 units of demand, then if there is an increase in demand, suddenly you'll not be able to satisfy that. So for that reason, what you do, you place a cushion over that anticipated demand. So that's the excess capacity, so that it can take care of the changes happening in the demand. So that's the cushion we are discussing here on capacity. What are the steps in capacity planning? Future capacity requirement, which is based on the forecasting, which we have seen in the previous chapter. We evaluate what do we have, what type of capacity we have right now. Then try to understand the gap between what is forecasted and what you can supply right now. We try to evaluate different alternatives, alternative A, B, and C. Maybe do a financial analysis of those alternatives. You access key quality issues. Which one is better and why? We get into that analysis. We select best alternatives for long run. After you have done that, again, this is a planning phase. We haven't executed. So judging all this, you choose the best capacity option, then you implement it. Now, capacity planning can be long-term, it can be short-term. We usually do long-term capacity planning for those commodities or for those areas where the change cannot be made that easily. When you are making a building, you should at least plan for the next 10 to 15 years, because it's not that easy to change that building that easily. But again, on the other hand, you are making capacity planning for a small retail store or maybe just the kitchen. You can make it for 1 year, because you know if the demand increases, you can make some changes much easily compared to that building. So this is long-term consideration and short-term consideration. This is again a small formula which we use to understand the number of machines that are required in a factory setting. It depends on the standard processing time for the product and the demand for the product. So PI and DI, one is the standard processing time and DI is the demand for product I. And you can have K number of products, so you will multiply this the time required and the demand, and you will add all those, okay, and after that you will divide it by the processing time available during the planning horizon. Say this demand is for a week, so how much time the machine is available in that week? So it's available for 35 hours and your total requirement is 200 hours. So you will divide it by the 35, you round it over, and you can calculate the number of machines required. The service capacity planning can be done in a similar fashion, but you will need to be near customers. That is, in service you are in direct contact with your customers, so which is little different from production. Then in service, if you plan the service, the problem is you cannot store the excess capacity. If you have more staff there, you have recruited them, but if you cannot put them into work, basically the man hour is lost. Unlike a piece of machine which can be stored, a building which can be stored, that man hour cannot be stored, it's lost. The other is the degree of demand volatility. The demand for service changes very frequently, and it's very difficult to match that demand with the supply. We use different strategies to offset capacity limitations, like pricing, promotion, discount. So these are the three prime ways you can offset capacity. For example, for winter garments in the summer, the demand is low. But in order to boost some demand, you might lower your price. Similarly with, say, air conditioners, in winter the demand for air conditioners are lower, so you can lower the price or do more promotion to boost up the demand. So these are all done to the offset capacity limitation. You try to spread the demand evenly as possible so that you can match the demand with the supply. This is another decision which organizations have to take, whether they're going to provide the service or produce the product in-house or whether they will outsource it. So a lot of companies, they do that. Say the demand increases, they cannot fulfill it themselves, so they hire a third party to get things done or to provide the service. Okay. So there are different factors which are to be considered. The expertise of the company you are hiring. Most important would be cost. Would it be too expensive to get things done by somebody outside your organization? Then what are the risks associated? You are outsourcing your proprietary information, okay, or your intellectual property. You are letting somebody use that. Is it beneficial in the long run? So these are some aspects you should keep in mind while outsourcing. Developing, again, there can be different alternatives of designing capacity, like design flexibility. You bring in flexibility in the design so that if required, it can be expanded. If not required, you can bring down the capacity. You can take stages of life cycle in the account. So say for a particular product, it has got different life cycle. If that product is in the decline phase, maybe if you're designing in that phase, you will not go for high design, because you know that in few years time the demand for the product will come down, or it might become zero. So you don't invest or in capacity where the product is on decline. Identify optimal operating level. That's important. At what level the cost of operation is the minimum. So these are to be kept in mind while developing capacity alternatives. Now, this is a convex curve, and we have the cost on the y-axis and the rate of output in the x-axis. At the lowest point of the curve, the cost is the minimum, and that is the level at which you should be doing your production. If you go beyond that, what happens is your cost of production increases. So initially what happened, the cost of production comes down. It goes to that lowest point, which is the optimum point, and then again it rises. Okay, so you should stop or try to stay as close to that optimum point as possible. In that way, the cost would be minimized. Anything close to that, the cost would be minimum. If you go beyond that, the cost again increases. Economies of scale. The economies of scale is related with the laws of return. You expand a capacity of a building, your economies of scale increases, or your return on the investment increases, but beyond certain point, again it starts decreasing. So you should find that point at which it is optimum. For different commodities, that might be different. So you have to do some market survey, or you should do a small experiment before you actually decide on the economies of scale. The diseconomies of scale is when you make things too big. So it is this curve basically. So this part is the economies of scale when the cost of production comes down, but beyond this vertical line, okay, this line, this optimum line, maybe OL, this is these economies of scale where the cost of production increases because things become too complicated. So as I said in the previous slide, you try to stay close to this optimum point as possible. You may not stay exactly at that point, but try to stay close by. And this can be done by doing market survey, or even for your own business, you study the cost of production over time and decide which is the best option. This curve shows basically the laws of return for small scale, medium scale, and large scale plant. So for the small scale, this is the equilibrium point, and this is the cost small. And if I go to that large firm, this is the equilibrium point, and this is the cost large. So what you see is the cost large is below the cost small. So if you make a bigger factory, the equilibrium point is lower. That means you can produce goods at a lower cost. But only problem is you should have sufficient demand. You should have sufficient demand to reach that output level. Otherwise, it is overproduction, which is not good again. Constraint management, something that limits the performance of a process or systems in achieving its goal. So in every business there are some constraints. Some of them are the market, your resource, your material, your finance. Now market, you have your own market share. Say this is the whole market, your market share is that. So that shaded portion is your market share. You cannot reach other customers. So that is a constraint. Your resources. So this is your resources. This is your raw material sources. So those are, again, maybe if you need more raw material, you don't have enough of suppliers. Same with material. You need material for your manufacturing, but there are some constraints. How much your suppliers can supply. Financial. Your lending organization is stopping you from going beyond. Resolving constraint issues, identify the most pressing constraint. Okay, so most important is finance. So how do you remove that financial constraint? Change the operation to achieve maximum benefit given the constraint. Okay, this is again this is called a optimization problem. You have an objective, say, which might be to maximize your production, but you have certain constraints which are your limitations. They are basically pulling you down. So based on those constraints, you try to achieve your objective as much as possible. Okay, this is a standard optimization problem in operations research. Evaluating alternatives. Now this slide is really important. There are different techniques for evaluating alternatives: cost volume analysis, financial analysis, decision theory, waiting line analysis. So you use all those techniques to evaluate alternatives. You have alternative A, B, and C. So you can use some of these techniques to decide which is the best. Say after implementing those evaluating options, you come to the decision that alternative B is the best. Okay, for non-economic activities, you have to take public opinion. Say you are building a park, so you should get public opinion to decide which is the best alternative. The cost volume analysis. So in cost volume analysis, we first comes into picture the fixed cost, then the variable cost, and the total cost. The total cost is the variable cost multiplied by the quantity. Okay, plus the fixed cost. The total revenue is the revenue per unit multiplied by Q. So you have total cost and total revenue. You make a profit when the total revenue is higher than the total cost. Okay, so this is what I was saying. The profit is equal to total revenue minus total cost. The revenue is R, which is the revenue per unit, or the selling price per unit, multiplied by Q, and total cost, this part here, is the total cost. This is the fixed cost, plus V is the variable cost per unit, and this is the quantity produced. We take this Q in one side, so the Q break even is equal to fixed cost divided by R minus V. Break-even point is that point where the production cost and the revenue or your income is equal. So you are not basically making any profit. The profit is zero, and then try to find that break-even point. So if you look at this graph, this line here, that's the fixed cost. You have your total variable cost. You add those two here, which will give you the total cost. Okay, and this is the total revenue. If I put those together, so this dotted line over here, is the total cost curve. When the total cost is over the revenue, that means you are spending more than your income, you are having this loss. But after the break-even point, what happens? The total revenue is higher than the total cost, so you are making profit. So this is a very important concept. You should all understand this. The cost volume analysis is a tool for comparing capacity alternatives if certain assumptions are satisfied. We assume that one product is involved. Again, this is not true, but we assume it to get to some decision, to solve that problem. Everything produced can be sold. Okay. The variable cost per unit is the same, which is not true. The variable cost can vary. For the first 100 it can be something, for the next 100 it can be something different. But to make our life simple, we have done these assumptions. The fixed costs do not change with the volume change. Again, this may not be true always. So these assumptions are made just to make our life simple, so we can solve it and get some understanding where the break-even point is. The cash flow, which is the difference between the cash received from the sales and other sources and the cash outflow. So the cash flow is basically, we sometimes draw a arrow diagram. The upward arrow stands for whatever comes in. Okay. The downward arrow stands for whatever we spend. The difference of these two, the upward arrow, which is our income, and the downward arrow is what is our expenditure. The difference of these will give us the net cash flow. The present value is, if you bring all these cash flows to today's date, say times 0, that is the present value. So cash flow we have already discussed in the previous slide. Present value, which is again a very important concept. You have your cash flows, you have your cash which is flowing in, which, as I said before, I demonstrate that with upward arrows. Whatever we spend, we show that by downward arrows. Now to compare all this cost, we need to bring it to one particular time frame, which is day 0, that is today, and then we compare whether we are positive or negative. So our chapter ends there, and we had a brief discussion on how a business organization decides on capacity. Thank you.